Hey everyone, welcome back to the eCoreAcademy e-learning platform. My name is AJay back with yet another Algebra 1 video for you all. And this next lesson topic that we're going to be covering is all about solving quadratic equations using the properties of square roots. Now, if you check out the previous video, the predecessing video to this video, it's all about the properties of radicals, essentially. So we're going to be taking quadratic equations that has to do with x squared and utilizing the property of square roots to essentially find and identify the value of x in these equations. Now, before we get into this video, please make sure to do 4 things. Make sure to hit that subscribe button, turn on that post notification bell, hit that like button on this video, and also feel free to drop a comment down below. We do appreciate feedback and suggestion for future videos. So without further ado, let's jump right into the video. So first thing that I want to clear up is that when it comes to solving these quadratic equations with our radicals, our square roots, it's specifically going to be with standard form that we're working with today. So we're only working with standard form. With obviously vertex form, it's factored essentially. So you would use the properties of factoring to actually get your value of x. However, with standard form, you'd merely use your square roots properties because you have x isolated. All right, so we're going to be solving standard form equations using square roots. So let's revisit what the standard form equation is. That's ax squared plus bx plus c equals obviously your f of x, your function, or in this case, 0. So a obviously is the constant that's multiplied with x squared. It's the stretch factor, same as in the vertex form, essentially identifying how much your graph is going to be stretched or compressed in that case. And then obviously b is the constant multiplied with x, and the property of b is essentially it pulls the parabola off of the y-axis a bit differently than h in the vertex form, but it still helps pull it off the more it magnifies itself. And then obviously x is your x-coordinate that you're plugging in, just as you would in x squared. And then c is the y-intercept of the parabola, one of the defining features of the standard form, something you can pick out without actually having to do any computation. And this is just 0 in place of f of x, or the y-coordinate in this case. So now that we've covered the basic standard form equation, let's look at a radicals recap. So how exactly radicals work? Well, the main thing that we focused on was the product property of square roots when it comes to simplifying these radicals and taking any proper radicals just like you would in an improper fraction. If a fraction can be simplified further, you're doing the same thing with the product property. So the product property of square roots states that the square root of AB multiplied together equals the individual square roots of A and the square root of B multiplied together when both A and B are both greater than or equal to 0. So obviously they cannot be negatives because there's no such thing as a negative there's no such thing as a square root of a negative. So when it comes to variables inside of a radical symbol, you want to find the largest even number that fits into the exponent, divide it in half, and take that value as your square root. So if we have an exponent like x to the 11th inside of a radical, essentially being square rooted, what you would do is you take the largest even number that fits within 11, so that's 10. You divide it in half, that's 5. And then you take that out of the radical and leave x to the first inside the radical. So x to the 5th times the square root of x to the first essentially is x to the square root of x to the 11th. All right, now let's take a look at some practice to actually solve these quadratic equations in standard form using our square roots. So let's calculate the solutions to the following equations. These are fairly simple standard form equations. So we're given here that x squared equals 400. This can be written as x squared minus 400 equals 0, but we merely moved it to the right-hand side of the equation. So x squared equals 400. So where do we start? Well, right off the bat, you should know your basic squares here, your common squares. So if you think about 400, its square root is essentially 20. So what we're going to be doing is merely square rooting both sides to isolate x. So square root of x squared equals the square root of 400. And we're left with that this square root of 400. It isn't just positive 20. It's actually positive and negative 20. Now, if you think about it, if you reverse the order, 400 can be created in 2 ways when squaring 2 different sets of numbers. So you can do positive 20 times positive 20, that equals 400. But when you multiply 2 negatives together, you also get a positive. So you can multiply negative 20 with negative 20 to get 400. So in this case, it's x equals plus or minus, which just means positive or negative 20. And then on the right-hand side of this of the screen, obviously, we have x squared equals negative 400, the opposite of 400. So we're going to square root both sides to start off with to isolate x. because we're solving for x. We're looking for the square root of negative 400. And in this case, we know that you can never find the square root of a negative. It's impossible. No two numbers of the same identity, the same sign, can be multiplied together to get a negative. So that means that this is essentially a no solution problem. There's no possible solution. All right, now let's move on. Let's take a look at some more problems. Let's calculate the solution to these following equations, and we'll start to build up in the difficulty. So we're given this equation here, 7x squared equals 112. Obviously, this is a lot more challenging than our previous slide. X isn't alone in this case, so first thing we have to do is isolate x, and also we're dealing with larger numbers like 112, so it's going to be a bit more computational work, but it's the same exact principles. So first thing that we do is obviously isolate x from both sides of the equation. Isolate x on the left-hand side of the equation, so we divide 7 from both sides of the equation. When we divide 7, we're left with x squared on the left-hand side, and then 112 divided by 7, that's going to be 16. So we're left with x squared equals 16. Now we can merely square root both sides. We're left with x isolated, and this equals the given value of the square root of 16, which is a clean digit. It's 4, merely. So that's going to be the answer here. So x is going to equal 4. All right, now let's take a look at the equation on the right-hand side. So remember, first thing that we're going to do, we're always going to isolate our x squared, and then we're going to always square root that x to get x isolated. So we're going to divide by negative 3 here to get rid of that on the left-hand side. We're going to divide it by on both sides, obviously. We're left with x squared on the left-hand side. Then on the right-hand side, negatives cancel out. 24 divided by 3, that's 8. So we're left with x squared equals 8. Now we're going to square root both sides. So the square root of x squared, that's merely x. Then the square root of 8, we're going to simplify that further. 8 can be split into the square root of 4 times the square root of 2. We know that 4 is a perfect square, so this simplifies to 2. So we're left with 2 times the square root of 2. And that's our answer here. All right, now let's take a look at some more challenging standard form problems that involve an extra amount. So essentially, it's going to be like a trinomial that we're looking at. Our standard form equation is literally a trinomial where you have your a variable, a coefficient attached to the x squared, your b attached to x, and then obviously your c as your constant. So we have a trinomial in this case. So we have negative 5x squared minus 19 equals 144. Well, the first step here is we're going to take negative 19 and essentially move it to the right-hand side. So we're trying to isolate x squared as quickly as possible, but also as efficiently as possible. We don't want to divide both sides by negative 5. That'd be too complicated. So we're going to add 19 to both sides. We're left with negative 5x squared equals 163. Then, of course, the next step is to isolate x squared. So we're going to divide both sides by negative 5. And we're left with x squared equals, and if you obviously plug this into a calculator, 163 divided by negative 5, it's about 32 3/5, or 32.6. So, and obviously a negative. So this is negative 32.6 because it's 163 divided by negative 5. Now, we actually don't need to continue further in square rooting both sides, essentially. Because if we square root both sides, let me clear this out. We're taking the square root of negative 32 3/5. Now, that should automatically raise an alarm. There's a negative symbol here. So you can never find the negative, a square root of a negative number. So in this case, we can automatically end this problem. We see that x is equal to no solution. All right, now let's take a look at our second problem on the screen. We have 2x squared plus 17 equals 209. So obviously the first step is to subtract 17 from both sides. Minus 17, minus 17, and we're left with 2x squared equals 192. All right, so next thing that we're going to do, obviously, we want to isolate x squared. So we're going to divide both sides by 2. And x squared equals, in this case, 192 divided by 2 is 96. Last step, obviously, is to square root both sides so that we get x isolated on the left-hand side. So we're going to square root both sides. So that simplifies to x equals, and in this case, we want to try and split up 96, multiply essentially take out its largest square that is a factor of itself. So the largest square that fits into 96 is going to be 16. So 16 times 5 is how you're going to simplify it. So we're going to isolate 16 here. 16 times 5. Obviously, we're going to take out that 16 because the square root of 16 is 4. So we're left with x equals 4 times the square root of 5. And that's your answer. All right, now let's end off the video with a little bit more of a challenging word problem. So this word problem is all about telephone poles, and it has to do with the Pythagorean theorem. So at a cross-section of a local highway, a telephone pole has just been added and hasn't fully been secured on its own. A wire is strung on the top of the pole and secured at the bottom to give it support from any high-speed winds or weather. The height of the pole and the distance from its base to the end of the wire are the same distance. The wire has a length of 200 feet. What is the height and what is the base, essentially? So let's take a look at this from a graphical standpoint. Let's solve it. So essentially what we're looking at is basically a triangle. It's a right triangle, and we're literally going to have to use a Pythagorean theorem to solve for two unknown sides. So here, on this left-hand side, that's the telephone pole. It's essentially standing upwards. This side right here, this long side, that C side, your hypotenuse is going to be your wire. It's literally securing the top of the telephone pole to the ground. And obviously the very bottom is the base. It's the distance from the bottom of the wire that's literally secured to the ground to the very base of the pole. That's the distance that we're looking at. And now in terms of variables, well, we can assign the telephone pole and the base distance as x, because the problem said that the telephone pole's height and the distance between the base of the wire and the telephone pole is equal. So that means we can label both as x to make it as smooth as possible. And then obviously we're also given the length of the wire, the hypotenuse, which is 200 feet. So now this is actually a fairly simple problem now. It was quite wordy, and oftentimes it's difficult to break it apart, but always draw images when you're confused. So what we're going to do here is we're going to set up our Pythagorean theorem because we're trying to solve for unknown sides of a right triangle when we're given one. So we're going to set it up in such a way that obviously a squared plus b squared equals c squared is the equation. We know that this side is going to be our a, but base is going to be b, and obviously our hypotenuse is c. So we can plug in those values that we know. We know that a is x, so it's going to be x squared. We know that b is also x because it's equivalent to the telephone pole. So that's also going to be x squared, and that equals 200 feet. Now, since we have x squared plus x squared equals 200 feet, we can literally just add together the x squared. So we get 2x squared in this case. Then we're obviously going to isolate x squared on the left-hand side, so we divide both sides by 2, and we're left with x squared equals 100 feet. And lastly, we're going to square root both sides to get x isolated on the left-hand side to get its equivalent integer value. So we're left with the square root of x squared and the square root of 100. That means that x equals, the square root of 100 is 10, so x equals 10 feet. So that means the base is going to equal 10 feet, and the telephone pole is going to also equal 10 feet. All right, everyone. Well, that's it for today's video. I hope you guys enjoyed. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Turn on post notifications, and also feel free to share using the bell icon, using the share button on YouTube, and turn on post notifications, obviously, so you don't miss out on any of our latest uploads. Check out our website at www.ecoreacademy.org to see what kind of, what kind of note sheets, quizzes, and worksheets, and all these resources that we have that go along with each and every single one of our videos, just like making up literally an entire platform for you to learn and cover all of your courses comfortably, and it's all for free, so check that out. We also have our Gmail open at eCoreAcademy@gmail.com. If you have any questions, you can always email us there. And check out all of our socials: Pinterest, Facebook, Twitter, Instagram, and TikTok. See what kind of cool content and interesting content we have out there, and use those mediums to share all of our videos to those who might need them. All right, everyone. Well, that's it for today's video. This has been AJ Raj, and I'll see you guys in the next one. Peace.